Our next topic for this unit is called stoichiometry. It's exactly what we've been doing except for you're given a chemical reaction. So with stoichiometry, you're able to predict the amounts of reactants and or products that will be involved in a chemical reaction. So that's the only difference, is that there's a chemical reaction involved. And so you're going to go from one substance to another substance. Whereas what we've been doing with just plain old mole problems is dealing with the same substance the whole time. This is why it's important to make sure that you're putting the substance in your conversion table. Now it's just like following a recipe. If you have a recipe that only feeds 4 people, but yet you're going to have a party and you need the recipe to be for 12 people, you've got to figure out how to change that recipe. So the stoichiometry provides the same exact thing, but with a conversion table. So a couple things to remember is, first, you must have a balanced chemical reaction. Now for the notes and also for your tests and things like that, you'll always be given a balanced equation already. So that'll be done for you. Now with the balanced reaction, you're able to do what's called a mole ratio, simply by looking at the coefficients given in the problem. Now you have to remember that coefficients are the big numbers out in front of the chemicals. The mole ratio gives you a relative amounts of reactants versus products. So for example, if we look at N2 plus 3H2 produces 2NH3, this is telling you that for every 1 N2, there must be 3 H2s to produce 2 NH3s. So if I give you a certain amount of something, you're able to go from one to the other. So you get these mole ratios, which simply come from your coefficients. So we know that 1 mole of N2 is needed for every 3 moles of H2. So you get a conversion factor that you're able to plug into your conversion table. So the same thing with N2 and NH3. With N2 we have a 1, with NH3 we have a 2. So 1 mole of N2 equals 2 moles of NH3. And again, these numbers are coming from those coefficients. So with H2 and NH3, we know we have 3 moles. Every 3 moles of H2 will produce 2 moles of NH3. So these are called mole ratios. So what does that mean? What are they good for? So let's try a problem. Now, in the beginning part of this notes, we're simply going to use the same reaction just so you can get an idea of what's going on. And then towards the end, we're going to switch up and do different reactions. So just like we've been doing with basic mole problems, you need to figure out your starting point and your ending point. So you're given 6 moles of H2. So we're going to start by writing 6 moles of H2. So like I've been stressing the whole entire time this unit, you need to make sure you put your number, your unit, and the substance. Now it's going to be extremely important that you put that substance, especially with stoichiometry. And then we draw our table. You're going to follow the same exact pattern that we've been doing the entire time. We have moles of H2 on top, so that means we need to put moles of H2 on the bottom. The same exact pattern. Now what is the question asking for? It's asking how many moles of N2 do you need? So we're going to put moles of N2 on top. Now, I have to retrain your brain a little bit here, because I have trained your brain that whenever you see moles, you put a 1. So now I need to retrain it. So the thing I need to retrain is, now when you have this mole on top of mole, so you have moles of something over moles of something else, you no longer are going to assume that you put a 1 there. You now, when you have mole on top of mole, are going to look at the coefficients in the chemical reaction. So for example, moles of N2, we're going to put a 1. With moles of H2, we're going to put a 3. Again, mole on top of mole, you look back at those coefficients. So moles of H2 cancel, and if you have 6 moles of H2, you now are able to tell me then how many moles of N2 that you need, simply by doing multiplying the top and dividing by the bottom. So 6 times 1 divided by 3 gives you 2 moles of N2. Extremely simple. Okay, so I now want you to pause the video and try the next example that's in your notes. Now check what you have in your notes compared to what I have on my paper. your answer should be 0.2 moles of N2 based on sig figs. So again, you start with your given, 0.5 moles of H2. You have moles of H2 on top, so you're going to put moles of H2 on the bottom. Whatever you're trying to get to goes on top, so in this case, moles of N2 goes on top. Then recognize that you have mole on top of mole here. Whenever you have that happen, you have to look back at the coefficients of the chemicals given to you. So N2 is 1, H2 is 3. Moles of H2 cancel, multiply the top, divide by the bottom, and you get 0.2. So does this mean that you always have this 1 and this 3 where they're at? Not necessarily. Okay, so let's try a couple more and then we'll move on to the harder stuff. So we have 4 moles of N2, so we can put 4 moles of N2 on top and draw your table. We have moles of N2 on top, so we're going to put moles of N2 on the bottom. Whatever you're trying to get to goes on top. So in this case, we're trying to get to moles of H2. Then recognize you have that mole over mole thing going on. So with N2, we're going to put the 1 on the bottom. With H2, we're going to put the 3 on the top with the H2. Moles of N2 cancel, multiply the top, divide by the bottom. Now, you may think it's 12, but you've got to think about those good old sig figs. 4 only has 1 sig fig, so therefore your answer can only have 1, so it's going to be 10 moles of H2 based on sig figs. Okay, so let's try one more of the easy ones, and then we're going to move on to the harder ones. Okay, so this time you're given 6 moles of H2, so 6 moles of H2, and draw your table. We have 6 moles of H2 on top, so we're going to put moles of H2 on the bottom. What is the question asking for? That always goes on top, so it's asking for moles of NH3 this time. So we're going to put moles of NH3 on top. Okay, so recognize you have that mole over mole stuff going on. So mole over mole, you look back at the coefficient that goes along with the chemical that's provided. So for NH3, we're going to use a 2. For H2, we use that 3 again. Okay, so moles of H2 go away. We're trying to find moles of NH3, so you just multiply the top, divide by the bottom. So 6 times 2 divided by 3, which gives you 4. So 4 moles of NH3 is your answer. Okay, if you have any questions about these simple mole to mole conversions, you need to make sure you bring them to class. Now, will you always be simply going from mole of one substance to moles of another? And the answer is no. So what we have to do is what's called the stoichiometry roadmap. Now we have the mole roadmap, and all we've done is we've taken one and attached it to another by using this mole ratio bridge. Now everything on this side of the map is about your given. Everything on this side of the map is about your unknown. Okay? And the only way to go from your given substance to your unknown substance is through that mole ratio bridge. You can't go across the water, you can't do any swimming or any kind of boating or any of that stuff. You must go across that bridge. Okay? So what I've done is for the examples, I have the example in front of me, and then I also have a map drawn for every single example. Now you are more than welcome to draw a map for each example, or you can just refer back to the one that's in your notes. Now I suggest when you do your homework and quizzes and things like that, you may want to draw a map for every single one so you can actually map out where you're going. So just like we've been doing, just like the whole time for this unit, figure out your starting point and your ending point. So in this case, we're starting with 4.04 grams of H2. So we are starting here, grams of H2. Okay, what is the question asking for? Grams of NH3. So we need to get to grams of NH3. Now, just like we've been doing with the regular map, you have to follow along the roads to get to where you're going. So we're going to start by writing our given. So 4.04 grams of H2. and draw your table. Now these are going to be extremely long, so make sure you have enough space. So we have grams of H2 on top, just the same pattern. We have grams of H2 on top. We're going to put grams of H2 on the bottom. So our first step is to go from grams to moles. So remember, with your conversion table, to figure out what goes on top, you look at where you're going in that particular step. So in this particular step, we're trying to get to moles of H2. Okay, we're still on the H2 side. Remember that all the bubbles on this side deal with your given, all the bubbles give over on here are your unknown. So this mole is still attached to the H2. Now, is this mole over mole? No. So for this mole, we are still going to put our one that we've been doing. With grams, just like we've been doing with basic mole problems, what do we need to find? We need to find its molar mass. So we're going to use mass of H2, which in this case, there's only hydrogen involved, which is 1, and there's 2 of them, so 1 times 2 is 2. So 2 grams goes there. Grams of H2 go away. We are left with moles of H2. Is that our final destination? No, we have not reached that final bubble that we're trying to get to. So we have to continue on. Our next step is we have moles of H2 on top, so now we're going to put it to the bottom. Okay, so we're here. We now need to cross the bridge and go to moles of our unknown. So we're going to put moles of NH3 on top. Okay, now this is where you need to recognize you have mole on top of mole here. Mole on top of mole, so you have to look back at those coefficients. So for NH3, we're going to put a 2. For H2, we're going to put a 3. Okay, so then moles of H2 go away. We are now at moles of NH3. Still, that is not our final destination, so we're going to keep on moving. We have moles of NH3 on top, so now we are going to put it to the bottom. Okay, and this step, we're going from moles of NH3 to now grams of NH3, so that goes on top. Okay, this part of the conversion table has nothing to do with the other parts of the table. So with moles here, I'm going to put that 1 because it's not mole on top of mole. With grams, just like we've been doing, you must do some side work. We need to find the molar mass of NH3. So there's only 1 of them with the mass of 14. Hydrogen, there's 3 of them with a mass of 1. So 14 plus 3 gives us 17. Moles of NH3 go away, and we are left with grams of NH3, which is what we need. So then how do you plug this in the calculator? And this sometimes can be the hardest part. You need to multiply the top, divide by the bottom. So when you plug this in the calculator, the easiest way to do it is parentheses 4.04 times 2 times 17 divided by parentheses 2 times 3, close parentheses. Okay, so 4.04 times 2 times 17 divided by 2 times 3. With sig figs, you're allowed 3, so your answer is 22.9 grams of NH3. Okay, so let's try another example that has a different chemical reaction. Okay, so let's treat it the exact same way we've been doing. Figure out your starting point and ending point, just using a different reaction this time. So how many grams of carbon monoxide are needed? So this means we're trying to get to grams of CO. And if you don't know what carbon monoxide is, the good thing about stoichiometry is it's in the chemical reaction. You just have to find it. So carbon monoxide is CO. Produced from the reaction of 16 grams of SO2. So this means we're starting with grams of SO2 with carbon. This means nothing. You only care about your given and your unknown. They may throw extra information in there, and if it confuses you, cross it out. Okay, you only care about the given information and the question piece of the problem. Okay, so we're just going to follow the steps. So we start with our given. 16 grams of SO2. Okay, we're at grams, so we're going to put grams of SO2 on the bottom. Our first destination, following our little map here, is to get to moles of SO2. So we're going to put moles of SO2 on top. So we have moles on top, not moles on the bottom, so we're going to put a 1 there. Grams of SO2, whenever you see grams, we must come over and do some side work and find the molar mass of SO2. So S, there's only one of them at 32.1 grams. Oxygen, there's 2 of them, each one weighing 16, which gives you 32. So 32.1 plus 32 gives you 64.1 grams. Okay, the grams go away. We are at moles of SO2, and we just keep on trucking. So we have moles of SO2 on top, so we can put moles of SO2 on the bottom. Our next destination is to go from moles of SO2 and cross the bridge and go to moles of CO. So we're going to put moles of CO on top. Now this is that new piece here, mole on top of mole. You must look at your coefficients. So with SO2, we're going to put a 2. With carbon monoxide, we're going to put a 4 and plug it in. Moles of SO2 go away. We are at moles of carbon monoxide, and we are not done yet, so keep on moving. So we have moles of CO, so we're going to put moles of CO on the bottom. We're trying to get to, in this step, moles of CO going to grams of CO. So you put that on top. Now remember, this has nothing to do with anything else in the problem. So you just look at what conversion goes here. So with moles, I'm going to put 1. With grams, what do? Molar mass. So we need the molar mass of CO. So carbon, there's only 1 of them at a mass of 12. Oxygen, there's only 1 of them with a mass of 16. So 12 plus 16 gives you 28. Okay, moles of CO go away. We are at our final destination, so now you need to plug it in. Make sure you're plugging it in with me so you're putting it in the calculator correctly. So you multiply the top, divide by the bottom. So 16 times 4 times 28 divided by parentheses 64.1 times 2 close parentheses. So your answer, based on 3 sig figs, which is what's given to you in the problem, is going to be, the calculator says 13.978, so that 7 rounds the 9 up, which makes it 14.0 grams of carbon monoxide. Okay? We are going to do one more, and then you are going to do the last one by yourself. And you're going to check. Okay? So I'm going to run through this one hopefully fairly quickly here. So how many formula units of lead 2 iodide are there? So formula units, you've got to remember, means we're trying to find particles of lead 2 iodide. So the question is, what is lead 2 iodide? If you don't know how to do the whole crisscrossing thing still, you should know that lead 2 iodide is that. So we're trying to get to PbI2. Are produced when 58.2 grams of Ki. So this means we're here starting at grams of potassium iodide. React with excess lead 2 nitrate. Now that's the piece that may throw students off, has nothing to do with the problem. It's just telling you that you have enough of it. So you only care about the number and what the question's asking for. And then you just follow the path. So we're going to start by writing 58.2 grams of Ki. Okay? So we have grams on top, so we're going to put grams on the bottom. First destination, we're at grams, and we need to get to moles of Ki. So that goes on top. Now we have moles, but do we have mole on the bottom? No, so that means that's going to be our 1. With grams, what do we need to find? Molar mass. So for Ki, K has a mass of 39.1, and there's only 1 of them. I has a mass of 126.9. So when you add that up, 126.9 plus 39.1, you get a mass of 166. So you plug it in. Grams of Ki go away. Our next step, we are at moles of Ki. So the next step that we need to go to is we're going to go from moles of Ki on over to moles of PbI2. So we have moles of Ki on top, so we're going to put moles of Ki on the bottom. Remember, whatever you're trying to get to in that step goes on top. So for this one, we're going to moles of PbI2. Now, this is the piece where the retraining of the brain, mole over mole, you have to look back at your coefficients. So for PbI2, we have a 1. For Ki, we have a 2. Okay, so moles of Ki cancel. We are left with moles of PbI2. That is not what the question is asking for. The question is asking for particles. So this means we have to keep on going with our table. So we have moles of PbI2 on top. So now we're going to put it to the bottom. Then our final step is to go from moles of PbI2 to particles of PbI2. And more specifically, this question is asking for formula units of PbI2. So we're going to put formula units on top. Okay, so we have formula units on top of moles. So this is not mole over mole, so this becomes 1. And then with formula units, just like we've been doing the entire unit, is a type of particle, so we're going to use 6.02 times 10 to the second. Moles cancel. We're left with formula units of lead to iodide, which is what the question is asking for. So now to get your answer, you simply multiply the top, divide by the bottom. Now remember, when you divide by the bottom, you need to make sure that you put parentheses around it. So you get 58.2 times 6.02 times 10 to the 23rd divided by parentheses 166 times 2, close parentheses. Based on sig figs, you're allowed 3, so your answer should be 1.06 times 10 to the 23rd formula units of PbI2. Okay, now in your notes you have one last problem. What I want you to do is to pause the video and try the next problem on your own. When you're done, please come back to the video and check your answer. So for the last example, you should have realized that you're starting with 5.00 liters of carbon dioxide, so you're starting here. And the question is asking for grams of calcium carbonate, so you're going to go to grams of CaCO3. So your first step is to go from liters to moles, and then you have to cross over that mole bridge, so you get the mole over mole. In this case, they both have a coefficient of 1. And then the last step, go from moles to grams. So you must calculate the molar mass of CaCO3, which you get 100.1 grams of CaCO3. If you have any questions, please bring them to class